Okay, so today's topic is going to be something I call mixed ANOVA. You'll hear other people use other terms for it. It's the term I use. I'm not the only person who uses that term, but you might see it show up differently at different places. So today, like I said, mixed ANOVA, and you'll see that, in fact, this is going to be kind of the culmination of where we've been going. So far we've talked about simple between designs and simple within designs. That's just one-way analysis of variance, either repeated measures, which we just did last time, or the thing we did, I think, before the break, right, which was just vanilla one-way analysis of variance, separate groups. Those are pretty simple designs. They got one variable. We've done a factorial between and within. So factorial designs, of course, are those ones like, they have like a 3 by 2 or a 2 by 2, something like that. And we've shown those being between and within. We've done both of those. Between subjects just means there are different subjects in each group, different subjects at different levels of each variable. And within subjects means it's all the same people. Well, we've had both of those. We did the within subjects example just last time. What about putting them together? Well, obviously we're going to do that too. So that's what we do today. Let's put them together. Yeah, let's do that. All right. So you might say, well, why? It just sounds like something more complicated to do. Well, there's actually a lot of cases where we might need this. So we might want one between subjects variable and one within subjects variable. Let's say we're comparing two species in their learning. Okay, so let's say we're comparing black-capped chickadees and dark-eyed juncos in their memory for food for locations in an aviary. Let's just say I'm doing that. Let's just say I spent 4.5 years of my life doing that. Well, obviously, if I'm looking at learning, I want to see change over time. But species is independent groups. We can't say, oh, well, today there'll be chickadees and tomorrow there'll be juncos. It's not something we can do, right? Or sex difference is a very, very big thing in psychology over the years. Has been looking at differences between male and female humans and other animals in cognitive tests, etc. So there's a long tradition of doing this, and it's an interesting and good one. Find a lot of times that a lot of things we think were out there really weren't, but there are a couple things that are pretty reliable. Either way, it's an interesting thing, and we can't randomly assign people to sex. That's just not something you can do. And there's other things, so obviously, etc. Right, so here's an example. Let's say we have two kinds of memory tests, an implicit and an explicit test. In fact, this was the example I used at the end of last class, talking about doing a 2 by 3 completely within design. Now this one, on the other hand, I've got different subjects being given the implicit test versus the explicit test. An implicit memory test is something like word fragment completion. I give you a bunch of, you study some words, and then you see the word with some letters missing, you fill it in. That's an implicit test. An explicit test is, tell me the words I just told you. Okay? And some of you are in my memory class and know this stuff. And then there's some retention intervals, 5 minutes, 1 hour, and 24 hours. You might say, Dave, you just said last time, you said we just do this with all the same people. Why are we doing it with two different groups? Well, maybe you have some concern that the implicit test gets contaminated. So in other words, if I do the, so I'm a subject at the experiment's point, if I do the implicit part, filling in the word fragments, maybe it messes with the explicit part. Maybe it then, me saying the word coffee, because I saw that word before, helps me remember the word coffee. Now, those of you, again, in the memory class know that that won't happen. But at the beginning, when people first studied implicit memory, that was always done, because like these two tests could contaminate each other. Okay? There's a very specific time they can. But it's beyond the scope of this course, or I didn't even talk about it in memory class because it's not that interesting. And it's something I discovered that it was that interesting. So it clearly can't be that interesting, because if I was going to feed my own ego in front of a class, well, I do that with food story word work. We still want a decay function. We still want to see over time the implicit memory people. Do they decline? And the explicit memory, do they? Well, and again, if you're in my memory class, you know the implicit one will not decline. We will not get a forgetting curve. We'll get a forgetting curve, which shows no forgetting. And the explicit one will get a standard forgetting curve, which is like Ebbinghaus found. Ebbinghaus and his comically large beard. All right. So what are the sources of variation here? Oh, by the way, I'm just saying that group 1 is subjects 1 to 10, group 2 is subjects 11 to 20. to 20 people in this experiment. Well, test type, implicit or explicit. So most of this is going to look exactly like we've seen before. There's going to be one thing that changes here, guys. Retention interval. So far this is exactly the same sources of variation. It shouldn't surprise you. Of course it is. It's basically the same design. We've just changed it to have two groups instead of one. Okay, that's harder. That's new. That's different. Subjects within test type. The brackets mean within. In fact, more technically, you would say subjects nested within test type. You see what it says, nested within? Because they're inside it. Because different subjects are in this kind of test, and the implicit, and different subjects are the explicit. So what we have now is we have one variable that is a between subjects variable, because different subjects get different levels of it, memory test type. And then we have one variable that is a within subjects variable. And we can see that because everybody gets every level of retention interval. Do you have questions so far? Does this design make sense? I think this is something that when I know you guys are in third year, you've been reading papers, you took 3286 to prepare for thesis next year, you've been reading stuff, you've seen designs like this. This shouldn't surprise you. If you've read an article in your life, you've a psychological paper, you've seen a design like this. Okay, so this is not a surprising design. Nothing weird about it, but this is weird. Subjects within test type, we haven't dealt with that before. All right. So this is the ANOVA summary table. It looks like this. Oh, there's a new thing coming into Yates order. Remember I said Yates order is this lovely algorithm that helps you get all the sources of variation and degrees of freedom? It's one of those weird things, too, that if you try to look it up, very few people use that term, and to the point where you probably won't find anything on the internet, actually, which is really strange to me. So, source of variation. Test. What you do is you list between subjects variables first. So if you go back and take a look at that, there is one between subjects variable. We know it's a between subjects variable because different subjects get different levels of test type. One group gets the implicit level, the other group gets the explicit level. Okay? Make sense? Okay. So we list that first. Remember before I said subjects and everything? No, because we hadn't dealt with this yet. So it's between subjects, then we talk about the subjects. Subjects nested within test. Now, we cannot go subjects within test by test. That makes no sense. So you do the next thing. Well, do we have any more independent variables? No, sorry, do we have any more between subjects variables? No, we just have within. Retention interval. And then the rest of it is easy. Retention interval by test, retention interval by subjects within test. And then when you take a look at, well, what do we divide by what for the ANOVA? Well, you just take a look for the term that you're interested in, and the one below it that has subjects in it, the same way as we did it before. So test, subjects within test. RI, so we take the mean square for test, divide by the mean square for subjects within test. The mean square for retention interval by the mean square for retention interval by subjects by test. The mean squared for retention interval by test, divided by the mean square for retention interval by subjects by test. And you see, I just followed a rule. Like I said, the Yates order is just an algorithm. It's a set of rules telling you how to do it, and it will always, if you do it right, it will always get you the right answer. Now let's look at the degrees of freedom. And then, well, first, any questions before I look at the degrees of freedom? We'll do some more examples, and I'll make up a couple after we finish recording. This becomes easy and mundane and annoying. I know right now it's like, but don't worry. Okay. Test. Well, that's easy. There's two types. Hopefully that was easy. And hopefully retention interval is an easy one, too. There's got to be 2 for that. Retention interval minus 1. The harder ones are the ones with subjects. So take a look at that first subjects one. It's subjects within test. It's little n minus 1. There are 10 subjects in each group. That's what little n is. Times the number of levels of test. So that's 9 times 2 is 18. Oh, that's what I wrote right there. And this one here, 2 times RI minus 1 times test minus 1. Oh, sorry, that's going to get you 2, because RI minus 1 times test minus 1 is going to give you 2, right? Because it's going to, there are 3 retention intervals and 2 test terms. So 2 times 1 is 1. Retention interval by subjects by test, and we have the same thing here. It ends up with 36. You sum those together, you get 59, you get 60 observations. You did it right. Or probably, if you total up the degrees of freedom and you got these terms wrong, chances are they won't come out right. Okay? It's not foolproof. You could make a mistake that's wrong, but right in somewhere else. That does happen. All right. So now I'm going to ask you questions on that. Do you see where I got everything? Now the expected values, we're not going to worry about it, but the reason that I told you all this expected values is because it allows us to figure out what to divide by what, but Yates order takes care of telling us what to divide by what. It just says, oh, test and the thing below with test with it and subject. So that one, and this one, and that one, and this one, and that one. So to review this, between subjects, within, this is one of those things I want you to say to yourself about 20 times before you go to bed at night. I want you to put like a piece of paper with the words between subjects, within, underneath your pillow. So you just internalize this. Because if you can remember that, you won't make any mistakes. And I kid you not, it is perfectly possible, and it happens every year, that people get perfect on the final exam. Because half of it is doing these things. Half of it. Right? Well, maybe 3/8. It's close to half. It's close to half the marks come from just doing these things. Okay? See, practice. And then do the interactions, right? This, cross this with this, cross this with this, and then you add another thing. And then figure out the error terms. And again, that's easy. If you've done it right, you just look for the thing that has it and subjects below it. Now this assumes everything is fixed and subjects are random. I'm not going to consider a situation where that isn't like that, okay? We deal with such things so rarely that we're not going to care. All right. Let's do another one. The n equals 5 in this one. You like what that does? That's it. We're not even going to worry about what the a's and b's are anymore. I'm just going to use a, b, and c. So what do we have here? We've got two groups. Oh, we've just made it more complicated by adding an extra variable. The first thing you want to do is list what are the between subjects variables. What are the between subjects variables here? We got 3 variables, a, b, and c. What are they? Or are there any? And you know it's a between subject variable if different subjects get different levels of that variable. And the levels are the numbers like 1 and 2. Just 2. Oh, the b goes up to 3. So which variable has different subjects get different levels of that variable? Just yell something out. There's only 3 letters there. Even if you guess, you got a 33% chance. I'm not going to answer the question. So somebody answer the question.
Is it G?
Oh, remember, G just means group.
Oh.
Yeah, so don't worry about G. But it gives you a hint, Justin. It tells you that group 1 is an A1, group 2 is an A2. So looking at the G's gives you the answer. It tells you that A is, in fact, the answer. Right? So you were almost there. So if we take a look, A is a between subjects variable. Because different subjects get different levels of A. Okay? All group 1 gets A1, group 2 gets A2. Are there any other independent variables that are between subjects? Where different subjects get different levels? Well, let's look at B. Well, who gets B1? Group 1 and group 2. Who gets B2? Group 1 and group 2. Who gets B3? Oh, everybody gets all levels of B because they're within the subject's variable. It must be. Figured. That's mine now. Very valid. It's a valuable pen. Wow, it's a paper mate. Very nice. Anyway, let's look at C. Let's see, who gets C1? What group 1 and group 2? Who gets C2? Group 1 and group 2. Okay, C is a within subjects variable as well. So we got 1 between, 2 within. My entire, all my time in graduate school, everything, not everything I did, because the human stuff I did wasn't like this, but everything else I did was all like this. It was 1 between, 2 within. Different kinds of things to remember, different retention intervals, different species. Species was always the between the subjects variable. Because again, I can't randomly assign subjects to species. So what we do now, put that over there. Between subjects within. The between variable is A, within are B and C. Subjects are always nested within the between subjects variable. Okay? So we know then that our first couple of lines of our source of variation degrees of freedom table is going to be A, S within A. Because A is the only between subjects variable, then you list the subjects. So far, questions? Are we good so far? I know it's a little weird. Okay. So it looks like that. Look how complicated that is. Look how many F-tests there are. There's a test for A, a test for C, a test for C by A, a test for B, a test for B by A, a test for B by C, and then the three-way interaction test. Okay, now, how did I do this? Remember I said the first thing you list is A because it's the between subjects variable. I know it looks like a lot, but watch how mechanical this is. Because I can see looks on some of your faces, and I mean, I can't see, and I can see the looks on some of your faces. I can smell the looks on some of your faces. That didn't make any sense. That was weird, sorry. Well, A is the between subjects variable, then subjects. Don't worry about the degrees of freedom yet. Don't worry about what you test with what. Yeah, just do this. A, S within A. Yeah, you pick one of the within subjects variables. I could have listed B first. I didn't, but I could have. I went with C instead. C by A, C by S within A. Done. Now the next one. B by A, B by S within A, B by C by A, B by C by S within A. Done. So you can see that there's a lot of stuff there, but the algorithms, it's a really simple set of rules. It's like I list some things and cross them with each other. So again, I list A, I list subjects within A. I can't cross subject within A by A, that is bizarre. C, then C by A, C by S within A, B by A, B by C by A, B by C by S within A. Okay, questions on just on the entries on the left side, the source of variation entries. Any questions on those? How I got them? Okay, the easiest thing to do is not worry about the degrees of freedom yet. Let's just worry about what we're testing with what. We'll test A by S within A, with S within A. We'll test this one, these two, with this error term. We'll test these two with this error term and these two with that error term. Just the one that below it that has subjects and it. If you're listening in on the podcast, I keep hitting the microphone that I'm wearing because I'm not convinced it's working. It is working. So now and then when you hear, that's just me going, hey, Vernie, it works. Okay. Degrees of freedom. You know how I attack this? How I used to attack these when I learned how to do this in school, and I was like, okay, how do I do these kind of problems? I would do this first. I would do this second. This is easy. If I've done this right, this will just be right. That's easy. Then I'll do the degrees of freedom. That's where I make mistakes. I'm going to make up an example today after we're finished recording. We're going to work on it, and I will make mistakes when I work through the example because it's easy to make mistakes, but it's easy to spot them. All right. Well, A is easy, A minus 1. Good. C and B are also easy. So far, let's just do the single terms, do them by themselves, and then work with the interactions. S within A is n minus 1 times A. Well, I said there were 10 subjects, right? So 10 minus 1 is 9 times 2 is 8. Okay, that's good. And it's all worked out here for how to do the rest of it. One of the things that's going to happen when you do this, if you do it right, is you should get this sort of Christmas tree type shape because of the way that the algorithm works. So you should always get the biggest term at the very bottom and the smallest term at the very top, and it should kind of go like this. So it's kind of, I always think of it kind of like a Christmas tree. If it doesn't come out looking like a Christmas tree, you may have made a mistake. Okay? It usually means, oh, I didn't, because it always has to do that, because it's this with this, this with this, this with this. I mean, it must work like that, right? 59 degrees of freedom, which is nice because, again, we had 60 observations. Beautiful. Okay, again, questions on this. That's a second example. All right. Oh, let's do more. Yeah. Let's do more. Indeed, as the title of the next slide says, yet another one. Okay, this looking weird. Oh, that one. Okay. Between subjects variables, who's got me? Tell me one. Different subjects at different levels of what? Let's look. And remember, when Justin said G before, he was right. Look for the G's and see where they're different. Okay? And then that'll tell you where the between subjects variables are. The different subjects get different levels of A or the same levels of A. It's a simple question, guys. It has two possible answers.
Different levels?
Yeah, they do. Don't be so tentative. You're right. Of course. And this isn't, I think the problem is you're all looking at this going, why is he asking this easy question? It's really easy. Different subjects get different levels of A. Look, A1, G1 and G2, A2, G3 and G4. Oh, look, it's the same. Okay, A is a between subjects variable. So is B. So is B, right? Because B1 is G1, G3, and B2 is G2, G4. Okay. Looks to me like C, everybody gets every level of C. C1, C2, C3. Okay. And I think, let's go with, I think I said 10 subjects per group again here. Maybe I'll see what I said, I don't know yet. Okay. Over there. This time both A and B are between. Subjects now, this is where it's interesting. How do we describe the subjects? They're nested within A-B combinations or A-B interactions. As you can see here, group 1 is in A1, B1. Group 4 is in A2, B2. Group 3 is in A2, B1. If you had 18 variables, you could add you had two levels, you have R2, D2. You could do that, because R is the 18th letter. Anyway, right. Subjects within AB, that's good. I said 6 per group this time. Oh, that's still going to be, looks like 60 observations, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, 12, so that's going to be 72 observations. We should end up with 71 degrees of freedom at the end. Okay, well, and now we list them. So let's do that. This is a little different because we have 2 variables that are between subjects variables. So we're going to do both of them. So A, then B, then A by B. Right? S within AB. Because we established that before, that different subjects have different levels of S. Okay. And then, well, we've done all the betweens. Let's do the within. C by A, C by B, C by A by B, C by S within AB. Done. And then look at this. A, B's, and C's are easy to do. It's got 1 level, 2 levels, good. N minus 1 is 5, right? Because 6 minus 1 is 5 times 2 times 2. 5 times 2 is 10 times 2 is 20. Okay. way through. Oh, and it adds up to 71 and 72 is the total number of observations, so 71 degrees of freedom. We did it right. I can tell you, by the way, that as I said, there'll be like at least 3 or probably maybe 4 of these on the final exam. I will be giving you so many practice problems. Don't worry. Things will start showing up on the LMS soon. Here's a practice thing. Do this. Here, do this. Here, do this. Don't worry. There's going to be lots of time for practice. Okay, that's not so bad. Notice how they all had A, B, C, but the tables look different because it's a B between or within. Okay, we're going to conclude talking about this, but then we're going to work out some just on the board for ourselves, okay? So, I won't be recording that part because what's the fun in that? These are incredibly common designs. In fact, they're probably the most common kind of designs in life sciences, actually, I might say, which is a between subjects variable and a within subjects variable. Very, very common. Especially common in psychology because we're often looking at change over time, learning, forgetting, etc. And then we compare 2 groups on those things. So knowing how to express the nesting stuff might be the hardest part of all of this. So it's subjects within A, B, or subjects within B, or whatever. What this does allow you to do is it allows you to pick the right term when you're using SPSS. Now, if you do this with SPSS, and there is a video on the LMS about how to do this, but if you do this with SPSS, what you do is you tell it, these are fixed factors, so all your all A's, B's, and C's, and say, and group is a random factor, and it'll figure this out for you. PSPP doesn't do that. So if you have PSPP to do this, you have to do it and then say, okay, I will figure out what the error terms are, I will do the division by hand of the mean squares. Well, the calculator. But if you do this, you're never going to pick the wrong one anyway. And really, like I said, the key to all of this stuff is just practice. It's truly just practice. It's not really horribly, eventually you'll find it not really horribly difficult. It's tedious. Doing this is tedious. Now you might say to me, Dave, and I would say, what? Because my name is Dave. You would say, well, Dave, and I'd say, you have to say my name twice. I know who I am. Why are you telling us this if you just said that it'll do it for us? Well, because it doesn't always do it. And sometimes people make mistakes. When I review articles for journals, which I do, we all do that, if I get something sent to me, one of the first things I do is I look at the stats. I go right to the results section. It's the first thing I look at. And I read it, and when they describe methods and results, when they describe their design, I take a look and go, okay, here's what the design looks like, here's what the mean squares should be, so I double check people, and it's under 10, but it's higher than 5% of the articles that I review for journals, people have done their stats wrong. And it's easy to catch. So I just catch it and tell people in the review, oh, you did that part wrong. Right? So this isn't something I think you should be scared of. It just involves some practice. Questions before we do some on our own and I stop recording? Okay, so let's hit that.